All right, so this is the 5-5 function composition assignment, and it seems like there's a lot of problems here, but they're all like super easy. I'm gonna leave, the easy ones for you guys. Like this is add, like just add these things, subtraction. Actually, the subtraction's worth talking about because a lot of kids will forget things. I don't know what's up with kids nowadays, but anyways, it's F, which is this guy, minus that guy. Now, you got to be careful because there's two things there, you know. Don't forget parentheses. So we have an x squared, we have a 2x minus an x, which is an x. We have a 1 minus a negative 4, which is plus 5. And that is f minus g of x. State the domain. When it comes to domain, you basically have three rules. And if you don't know these rules, you should probably write them down. All right, you have a rule about 1 over anything. That means anything. The deal is you cannot divide by 0. It's not a defined operation in mathematics. So anything is not 0. Plain and simple. Doesn't mean x is not 0. You have the square root of something. Well, I know that the smallest thing I can take the square root of and be real is 0. So the stuff inside has to be greater than or equal to 0. And the last one is a combination of these two rules. If you have 1 over the square root of anything, well, I have to kind of join these two things. All right, you see how I have not equal here and I have equal here, but I have the greater than? The equal to symbol has to disappear, but I keep the greater than symbol. And there are only three rules about domain. Now, I will notice, I call this square root. It's an even root. It's about being an even root. All right. So this is a parabola. And furthermore, it doesn't look like either one of these three rules of domain. So its domain is negative infinity to positive infinity, or maybe all real numbers. Sometimes a lot of people say that, all real numbers. Anywho, I'm not going to do the first one. I've done 4. Let's do 2. 2 is f over g. So here's f, here's g. So you have x squared plus 2x plus 1. And we're placing it over g, which is x minus 4. And I'm thinking about the 1 over anything rule. Can't be 0. Anything cannot be 0. So I know that x minus 4 is not allowed to be a 0, which means that x is not 4. Because if it was, I would be dividing by 0, and that cannot, shall not happen. So depending on how I write this, I can write this all values of x such that x is not 4, or I can use interval notation, negative infinity to 4, union with 4 to infinity, or I could even say something in English. I could say all real numbers except x equals 4. Write a sentence if you can write. 5 is g over f. So x minus 4 sitting pretty over x squared plus 2x plus 1. And again, it's the 1 over anything rule. Anything cannot be 0 because you cannot divide by 0. It's not a hard concept. I don't know why kids think it's just crazy, but it's not possible. So anyways, we're going to take x squared plus 2x plus 1. We're going to say she shall not be 0. And then we're going to factor x plus 1 times x plus 1 is how that thing factors. And we're going to use the not zero product property. All right, because that's what it is. It's the not zero product property. So x is negative 1. It does happen twice. You get the same thing from both factors, right? So anyways, all values of x such that x is not negative 1. Or maybe you like interval notation, negative infinity to negative 1, union with negative 1 to infinity is the far superior one. And ta-da! 6 I'm going to leave for y'all. 7 I'm going to leave for y'all. 8's got words, and I don't think you guys can read, so here we go. Suppose the demand D in units sold for a company's jeans at price X in dollars is demand as a function of x is 600 minus 4x. If revenue is price times demand, write the rule for the function. I don't know why I call it f of x, r of x, and then state the domain of this function. So this is price. There's something missing in this one. Because x is dollars. Demand is a function of that. Oh no. I'm sorry, I'm just having a moment here. Price is x. So revenue as a function of x is x times, because that's price, times demand, which is 600, minus 4x. And of course, you can put that in STD form. So revenue as a function of x is 600x minus 4x squared. Now that's not in standard form. You should obviously put that in standard form. So negative 4x squared plus 600x. That would be STD form. So if the price is 40 bucks, how much revenue, which is not profit, will the company earn? So the revenue, when x is 40, r sub 40 is negative 4 times a 40 squared plus 600 times a 40. So what do we get if we do 40 squared? What, 1600? Seems right. Pretty tired. I better check myself. But I feel like it's 1600. Milbrath is having a morning, apparently. Yeah. So anyways, this is 1600. So we got a negative 4 times 1600. And this will be plus 24,000. So that would be 6,400 plus 24,000, which is 17,600. There you go. Price will maximize revenue, and I'm even telling you where this happens. Again, it happens at the x coordinate of a vertex, happens at opposite b over 2a. So here is a 600 for b. This is the maximum price. Negative 600 over twice a negative 4. And that'll be positive. That's 600 over 8. And that would be what? 300 over 4. 150 over 2. $75. What was the maximum revenue? Well, the maximum revenue happens when you plug that 75 back in. It's a bad looking square there, isn't it? Let's just go ahead and erase that and start over. Sorry, I'm wasting your time. My hand is not doing what it's supposed to be doing here. Negative 4 times a 75 squared plus 600 times 75, because I plugged back into the original equation. All right, 22,500. So, you know, I'm sure people complain about how much things cost, but if I'm this guy, I'm charging $75. I'm not worried about your income, I'm worried about mine. All right, so we got the square root function. It says evaluate each expression, no decimals, just simplify the radical if possible. And then we'll see what we can do with it. So you're supposed to find f of g of 3. And g of 3, which is what I'm going to do first, is the root of 3 times 3 minus 1, which is root 8. And it does say simplify the radical if possible, and root 8 simplifies. I mean, God bless you, you do this in Algebra 1. It's 2 root 2. Now that I know what this is, I've got g of 3 being 2 root 2. I'm going to plug it in right there at that x. So f of g of 3 is actually 4 times 2 roots of 2 minus a 5. Now 4 times 2 is 8. So 8 roots of 2 minus a 5. All right. Then we have some function composition. Here you're supposed to find f of g of x, and do remember that that is f parentheses g of x, which means we're going to take all of g and we're going to put it right there. All right. Anyways, there's a 4. I encounter an x. The x gets replaced with the square root of 3x minus 1. And outside of that, I take away 5. Now, you talk about domain. There's this rule for domain. For the even root of anything, the stuff inside is greater than or equal to 0. So 3x minus 1 must be greater than or equal to 0. X 3, I guess I should show all the steps here. 3x is greater than 1, x is greater than or equal to a third. So I'm just going to do set builder, all values of x such that x is greater than or equal to a third. Twelve is g of f of x. So we're going to take f of x, we're going to put it right there. We have a square root symbol. We have a 3. We've encountered the x. It becomes 4x minus 5. Close the parentheses, and then we see a minus 1. So we have the square root of 12x minus 15 minus 1 minus 16. That's what g of f of x is. Now you state its domain. You could actually simplify this, if you're a major STEM guy like science, technology, engineering, mathematics. Let's see if this makes sense to you. You can pull the 4. That'll leave you with 3x minus 4, and the square root of 4 is 2. So 2 roots of 3x minus 4. But this is the reduced form. But anyways, most kids are going to be good there. So 12x minus 16 is bigger than or equal to 0 because we have the square root rule. So 12x is greater than or equal to 16. We divide out our 12. And 16 over 12 reduces down to 4/3. So all values of x such that x is greater than or equal to 4/3. Ta-da! All right, next up is division. F over g, that'd be 4x minus 5 over the root of 3x minus 1. And here's that 1 over an even root thing. Anything is not greater than or equal to 0, it's bigger than 0. So 3x minus 1 greater than 0. 3x greater than 1, x greater than a third. So all values of x such that x is bigger than 1/3. Easy peasy, lemon squeezy. I'm going to leave the numbers and stuff, whatever's left on this for you. Let's do golf. No. I'll do fog. Which, by the way, is, there needs to be a parentheses around that x. F of g of x. That is going in right there and right there. So 9 minus 2x, quantity squared, plus 9 minus 2x. I don't need the parentheses, I guess. To square something, one would write it twice. This is just going to be plus 9 minus 2x. So if I square, I'll have 81. I'll have a minus an 18x there. I'll have that happen again, which is minus 36x. And then I have a negative 2x times a negative 2x, which is plus 4x squared, plus 9 minus 2x. So we have a 4x squared, we have a negative 38x, and then we have 90. I didn't ask for it, but the domain for this thing is negative infinity to infinity, or all real numbers, or something along the lines of that. And the last one I'm going to do is a difference quotient. Read my note on 17. You are ready for this, as you should be. Well, you may not be ready for it, but the course is ready for it. So I'm supposed to find f of x plus h minus f of x sitting pretty over an h. So this says x is x plus h. I'm actually going to find that first. Everywhere I see an x, I'm an x plus an h. And it's supposed to be squared, so I'm just going to go ahead and write it twice. That way I can just save the line. So 2, so we have an x times an x, which is an x squared. We're going to have an xh here. We're going to have another one here. And xh plus xh is plus 2xh. And then we have h times h, which is h squared. I don't remember what I was thinking. So anyways, distributive property. And now we're going to distribute our 2. We'll have 2x squared plus 4xh. You know, in my day it was a c, not an h. Plus 2h squared. I wonder why they got rid of that. So minus 4x minus 4h plus 1. I know this seems like a lot of stuff, but it's calculus, kids. This is the derivative. Making sure I didn't make any mistakes. Now I'm going to take every bit of this and I'm going to put it right there because that's where it goes. 2x squared plus 4xh plus 2h squared minus, that's supposed to be an h, 4x minus 4h. And see what it says next? It says take away the original function. So I'm taking this away. And it's 2 or more, so I have to wrap. And then if you look, it says it's over an h. There's an h right there. So I'm going to put it all over an h. All right. Now, whatever you put in parentheses cancels. This stuff always cancels. Always. So there's a positive 2x squared and negative 2x squared. Gone. There is a negative 4x, but there's also take away a negative. Gone. And it seems like I'm missing the plus 1. I forgot to bring it down. There's 1, take away 1. So gone, gone. So if it exists in these parentheses, you get to cancel it out. That's how it works. If it exists in the parentheses, it cancels out. And now we're moving forward. What's left is a 4xh, a negative 4h, and there's a reason I'm changing the order, and a plus 2h squared. And it's all sitting over an h. Now I notice that each of the 3 terms up top has an h, so technically what I am doing is I am factoring it out. And only then, after then, am I supposed to cancel. And there is the derivative of 2x squared minus 4x plus 1, better known as the instantaneous rate of change. All right, I hope you like this section better than some of the other ones.